Yeah, today is actually a revision session for week 5 and 6. And we also solved some of the question based on week 5 and 6 itself. Yeah, question solving will be there after discussing a little bit of theory.
Hello, ma'am.
Yes.
Actually, I have a general doubt. Can you please clarify one?
Lakshan.
Yes, ma'am. Ma'am, actually, I want to know that for the final result, the maximum marks out of both the quiz will be considered, or some portion of marks from quiz 1 and some from quiz 2 will be considered.
I think they consider best one. I'm not sure. Can anyone answer this thing?
So ma'am, if I have scored a maximum like 100 in any one of the subject in quiz 1, then there is no need to give the quiz 2 of that subject, no?
I'm not sure. Let me check with someone. But it's better to give a quiz do now. You will get some practice only. Because at
Yes,
the
ma'am.
end term also, end term is important, right?
Yes, ma'am.
So at the end term, the whole syllabus will be there. So it's better if you practice something.
Yes, ma'am.
Ma'am, I think they are taking 10%
yes, ma'am.
from
Also
the
because
first quiz and
in
20% from the second one.
Okay, so is that the case? That 20, 20 and then 60, right?
Yes, ma'am, they're taking like that.
Ma'am, I have read that handbook which was provided by
1,
the
2, 3,
item.
4.
There it was written max
Hello.
Q1, Q2. So
Okay.
so they will take either if they will take the maximum of quiz 1 or quiz 2, or if the 20-30% ratio is higher, then they will take that. The 20% quiz 1, 30% quiz 2. Whatever is
whichever is the
higher, they will take.
maximum.
If
Whichever
the
is
max,
maximum.
yeah, they will take, or they will do 20% quiz 1 or 30% quiz 2.
Okay. Thank you so much. Thank you.
So does my screen is visible to everyone?
Yes, ma'am.
Yes, ma'am.
So I have selected some of the important question, which I think it's important in point of view of quiz 2. So we'll discuss these questions at the end of session. So first we will cover basic theory from week 5 and week 6. Since week 6 is just logarithmic function, and you guys are already gone through, I think, 2 lectures over that thing, right? One Hindi lectures and other one. But still I'll cover whatever main concepts are there. Okay. And after that, we'll solve some question, and at the end, we'll take doubts regarding week 5 and week 6. My voice is clear, right? Is there any disturbance?
बोल के देख.
Okay, so let's start. So we'll start from week 5. Right. In week 5, you guys are discussing about, we are discussing about the functions. What are the one function, onto functions, and what about the domain of a function, range of a function, and composite function. That's all we have, right? So let's start with the basic definition of function. So what do we mean by function? So a map or a relation or whatever correspondence is there, we can say that a map or a relation is said to be a function from a set A to a set B if certain condition holds. What are those conditions? First thing, that for all elements of A, that is for all A in A, there should exist a unique B in B in such a way that this A will map to this B via the function. That means B has a pre-image as A. And in the definition of function, there are 2 keywords. First thing is this every, that for all element or for every element of A, for all or every element of A, right, there should exist a unique B, right? So whenever we talk about function, if some expression is given to you or some correspondence is given to you, then you have to check these two properties, that for every element of A, there should exist an unique B in B in such a way that this map F will maps this A to this B, right? So this is a basic definition of function. So I'll give you a very simple example. Suppose this is our set A, this is our set B, and there are 4 elements are there. So name it to be 1, 2, 3, and 4. And in B, there are only one element, name it to be A, let's say, right? And if I define my F to be in this way, via this picture, then what do you think about this F? Is this map define a function or not?
Yes.
Is it a
No, ma'am,
function?
this is not a function. It is having
Yeah, it is not a function, right? Why? Because the elements of the domain is not mapped. 3 and 4 are not mapped. That's why it's not a function. It is violating the every property, right? We want every element of A should have an image in B. That's why this is not a function. Now, if I introduce some other elements in set B and define a function via this thing. Now, does it is this a function?
No, ma'am, it is
No,
giving
ma'am.
multiple outputs
No,
to
ma'am.
single input.
Right, because this function is mapping one input to different outputs, A and B, right? F is mapping this 4 to it, this A and this B also. So that's why this is not a function. So this is a very basic example how we understood the function, the definition of function actually. Okay. So now there is one vertical line test used for checking that if a graph is there, then you can draw a vertical line. So this is known as to be vertical line test for identifying any function. So if some graph is given to you, right? Suppose this is some graph is given to you, and if you draw a vertical line, any vertical line means a line which is parallel to y-axis, right? So if you draw any vertical line, and if that vertical line cuts your graph exactly once, right? That means any vertical line should cut the graph at most once only, at most once, right? So that means if any vertical line you draw and that vertical line is cutting your graph at most 1 point, then that graph will represent a function. Then this graph is a function. This graph is a function. Right? Why is this so? Because it's actually saying that for each x, there is one y. That means the uniqueness and the everything is there. Right? Now, suppose if I give you this graph of circle. Suppose this is my graph of circle, and I'm saying that the domain of this map, that the domain of map or the set A here is, and I'm giving that A is nothing but this close interval -1 to 1, and your B is actually again close interval -1 to 2. Then what do you think about this graph? Does this represents a function?
No, ma'am, this is not a function. It violates the vertical line test.
Right, correct. So if you draw any vertical line here, then that vertical line will intersect this graph at 2 points. That means at a single input, we have double output, not a unique output. That's why this graph does not represent a function, right? So this concept is here, I think. Now let's move toward the one-one function and onto function. Before that, let's define what do we understand by domain of a function. So in the previous definition, whatever the set A is, that set is known to be the domain of function. That means in the domain of function, we have to take all those points where your expression is valid. For example, if you take your function f of x to be 1 upon x, then you guys already know that at x is equals to 0, this quantity 1 by 0 is not defined, right? Because it's an infinite thing. So it is not defined. So that means this expression is not valid at x is equals to 0. So that's why the domain of this function will be the whole real number except this 0 point, right? So this is known to be the domain of function. Now the next thing is, what do we understand by the range of the function? So range is actually a set where we take all the points from the codomain which has a pre-index. And what do we understand by codomain? Sorry. So codomain is that set B. So if a map is if map is given from A to B, then this A is known to be the domain and this B is known to be the codomain, right? So what is range? So range is a sort of subset of a codomain where we take all over all those B belongs to B in such a way that there exists an A in A such that F maps A to B, right? So this subset of codomain is known to be the range of a function, right? In general, the finding the range is not that easy thing, but sometimes while looking the graph or while looking the nature of function, you can find out what is the range of that function. Or while looking the limit x goes to infinity and x goes to minus infinity, those all things will combine, tell you that what is the range of given function. Okay. So now let's move toward 1, 1 and on to function. So what do we mean by a 1, 1 function? So 1, 1 function means for a single output, there should exist a unique input. That means, that is, if x1 is not equals to x2, if you are taking two different inputs, then the corresponding output should be different. That means f of x1 is not equals to f of x2. Then we say f is 1. Right. So a 1, 1 function means there should be a 1, 1 correspondence. Right. For example, if we understand by a simple thing, suppose there are 3 elements here, 1, 2, and 3. And if I define this function like this, right? So this is some sort of 1, 1 correction, right? For every input, there is one single output. So such kind of function is known to be the 1, 1 function. Now, for checking a function is 1, 1 or not, there are 3 points we should remember. First thing is this. We have to check that first you have to assume that x1 not equals to x2, and this should imply that f of x1 is not equals to f of x2. Now, if you take the negation of this statement, what it will be that if f of x1 is not equals to f of x2, then it should, f of x1 is equals to f of x2 because we are taking negation, right? So here not is there. So in place of not, we have to take yes. That's why if f of x1 is equals to f of x2 is your hypothesis, then it should imply that the input is also equal, right? That means first statement is actually saying that if you take different inputs, the output will be different. And the second statement is saying if you take same output, then the corresponding inputs should be same, right? So these two are the arithmetical, statements which will be used for checking that a function is 1, 1 or not, right? For 1, 1 or not. In some cases, you just have to use your observations that a function is 1, 1 or not. For example, we saw a function that f of x is equals to x plus 1 by x, right? This function we already saw in some examples. So here, if you take simply x is equals to 2, then x1 is equals to 2 and x2 is equals to 1 by 2. Then here inputs are distinct, but if you find out the outputs, then f of x1 is simply 2 plus 1 by 2, and f of x2 is simply again 1 by 2 plus 2, right? Which is same as f of x. That means two different output is giving us same input, but there are two different inputs giving us the same output. That means this function is not a 1, 1 function, right? So these are two expressions which you should keep in mind for finding out that our function is 1, 1 or not. Okay. Now the third thing is what we know about horizontal line test, right? So horizontal line test you can use if a graph is given to you or you know the graph of that function, that particular function, right? So what does horizontal line test says? That if any horizontal line cuts the graph at most once, then we know that that function will be 1, 1. Then this will imply f is 1. Right. This is same as the vertical line test. In vertical line test, what we are doing, we are taking the vertical line. If it cuts the graph at more than one points, then that graph is not a function. But if you take a horizontal line, then it will say that corresponding to a same value, corresponding to a same y, if there exists two different x1 and x2, then that function is not a 1, 1 function. The very simple example of not being a 1, 1 function is f of x is equals to x squared. Right. So the graph of this function is right. So the graph of this function is actually this parabol, right? And if you draw a line y is equals to 1, then this line actually cuts the graph 2 times. So that means this is not a 1, 1 function. Okay. So is there any doubt in 1, 1 functions?
No, ma'am.
Okay.
Can you explain the range once again, please?
Yeah. So
I did not
range
get.
is, yeah. So range is what? So in range, what you have to do, there is one codomain set associated to every function, right? So if a function is defined from A to B, then this B is known to be a codomain set. Now from the codomain set, what you have to do, you have to pick all those elements which has pre-image. For example, if I define my function f of x to be equals to x square, and I'm saying that f is a function from real number to real number. Now this real number is a codomain for that function, right? But you observe via the graph that this function, this f of x, is actually not attaining any negative values, right? So any negative value of y, for any negative value of y, there's no input, right? There is no what you can say corresponding pre-image, because we cannot pick any x for which f of x is equals to minus. That means -1 or -2 or -3 are those points which belongs to your codomain, but they don't have any pre-image. So from there, you can say that the range of this function is actually the whole positive y-axis. Is that clear now?
Yeah, ma'am, clear. Thank
Yeah.
you.
Hello, ma'am.
Hello.
Huh?
Yeah, ma'am. You say some relationship between limit and range. I can't understand that.
Yeah, we will discuss that later in the, I'll solve some example, then it will be easy. Okay.
Ma'am,
Thank you, ma'am.
Hello.
Yes, Sarah.
Hello.
anyone wanted to ask? Can I ask?
Hello.
Yeah. Just go on.
Actually, ma'am, in case of composition of the functions, first we will find out the composite function, then we will look out whether it's 1, 1 or onto, right?
Via the composite function, I think you can do that, because that won't affect your oneness. Yeah, but you have to be clear about the domain first. That if at some point G is defined but F is not defined, and that input is giving you, I mean that those two inputs are giving you same output, then you can't. So I mean you can do that. There is no problem, but you have to be cautioned that which input you are taking, right? You have to be clear about your domain, that which points we can take as an inputs, right? Then after taking the expression, if you compute the 1, 1 oneness, I think that will be fine.
Okay.
Ma'am, we have to
Thank you,
be
ma'am.
cautious about the range of the inner function, na? That if it gives anything as in the range that outer function is not defined on, then we'll have a problem.
Yeah. So overall, we have to take care about the domain of composite function. I'm talking about F composite G entirely.
Yes.
That what input we can take. Right. Yes, Abhishek, you want to say something?
Ma'am, can you explain the second point of the function?
Your voice is very.
F(x1 equal to f(x2)?
Your voice is not clear. Just repeat it again.
Ma'am, can you explain the second point? It's f(x1 is equal to f(x2), where x1 is equal to f2.
Sorry, I'm not getting you. Can you type in chat box?
Ma'am, he's asking you to explain the
Huh.
second point where fx1 is equal to fx2.
Okay, this point. Okay, fine. Thank you. So here what's happening, this relation comes from the definition of one function, right? So what we are doing, it's very difficult sometimes to handle the inequalities, right? So what we want to do, we want to change this inequalities into equality. So for that, what we will do, we will take the negation of that statement, right? So negation of that statement means we will take this as a hypothesis, this as a conclusion, and negate both of the phrases. So if we take this thing, if we took this thing as a hypothesis and negate it, that will become f of x1 is equals to f of x2, right? And this will imply x1 is equals to x2. So ultimately what we are saying, the first statement says that if you took different inputs, your output should be different. And the second statement is saying if you take same output, then your input should be same, right? So both things are equal. Is that clear now?
Clear, ma'am.
One more thing, ma'am, I wanted to ask. Suppose there are two functions, one in 1, 1, one is 1, 1, and the another one is on 2. So the composition of these two functions will be 1, 1 or on 2.
No, we can't say anything about that, actually.
Achha,
Because,
I was confused.
because for composition function, there are certain rules there that if f composite G is bijective, 1, 1 and on 2, 1, 1 and on 2 function is known to be bijective. It actually implies that G is 1, 1 and f is on 2. This is a result you can observe via some calculations, but I'm just telling you, but the converse is not true. F and G being 1, 1 and f is being on 2 does not imply actually f composite G is bijective. So you have to check first that everything is going well or not. If both of the functions are bijective, then you can imply that your composite function is bijective. Otherwise, you can't say anything. It's bijective.
Sir,
Okay.
ma'am, how do we know that like G is 1, 1? Is there any like reasoning or proof?
Actually, you can use. There is some arithmetic proof only. They adjust it in some way so that it comes out to be. It's based on higher mathematics. That's why I'm not telling here. Okay.
These
You can
1,
look up
1
more
and
into
on 2
it.
concepts are a bit confusing. I always get confused in these.
Okay.
And
Yeah, because
mostly in case of composition, like
huh,
it's really difficult, I think.
yeah,
Ma'am,
that's the kind of thing.
ma'am,
Yeah, Praveen.
if a function is always increasing in its whole domain, in its entire domain, can we say that the function is 1, 1, or if it is always increasing in its entire domain or always decreasing in its entire domain, can we say that this function is
Yeah, that's the result. Because what happened if it is a strictly increasing or strictly decreasing function, now then you know that the graph of function something like either look like this or look like this kind of thing, right? So here, if you take different inputs, then via graph only, you can say that it will satisfy the horizontal line test, right? So if a function is entirely increasing or entirely decreasing, but it should not be a constant function, right? Should be strictly increasing or strictly decreasing kind of thing happen. Then only
Okay,
you can say it's a 1, 1 function.
Ma'am,
Yes.
strictly increasing does not imply that there is any saddle point.
Strictly increase. Sorry, what? Uday?
As ma'am, the function is strictly increasing. So it implies that there is any saddle point. Means the function becomes constant for a while.
No. Strictly increasing means it should satisfy this condition. If x1 is less than or strictly less than x2, then it should imply f of x1 is strictly less than f of x2. So then in this strictly increasing case, a function can't behave like a constant function over any subinterval or any part of the domain, right? So then only we can say it's a 1, 1 function.
Okay, ma'am.
Yeah. Okay. Now let's move toward onto. So again, onto function are those functions that if the range of f is same as the codomain, then we say it's an onto function. That means every element of codomain. So that is every element of codomain should have a pre-image. Right. So that means if your function is, in your function, if codomain is same as the range, then we say that that function is onto function. Via graphically, how you understand that function is onto or not, you have to check that every point of y should be mapped via function. For example, if I draw a function in this way, this is my function, suppose this is some parabola, then you observe that any point which is below this this point, suppose this is -1, then this -2 does not have any x, any corresponding x, right? So that means this function is not onto. And if I am saying that this is a function from real number to real, right? Here codomain is the whole real numbers, but all the negative real number does not have any pre-image. That's why this function is not onto, right? So the definition is clear. For finding out that it is an onto function or not, there are so many ways, observation or limit and all those things. We'll come back to that when we solve some example there. Okay. Yes, Deepak.
Can you explain that reversible?
Reversible. What thing?
Ma'am, inverse of function, है ना?
Inverse of function. Reversible. Okay. So again, if a function is if f is 1, 1 as well as onto, then that function is known to be a bijective function, right? And for a bijective function, there exists an inverse. So what do we mean by inverse of function? So inverse of f is actually that function g in such a way that g composite f of x is equals to x. That means if we compose g and f, it should be equals to the identity function, and if we compose f with g, then it should be an identity function. That function g is known to be the inverse of function f, right? And this g is actually denoted by f inverse, right? F inverse is just a symbol for denoting that a function is the inverse of that function, right? So composition of function is via definition, it's clear that g composite f of x is actually equals to that g of f of x. That means in place of x, first you have to took first at x you have to apply f, and after that you have to apply g. That is known to be the composition of function, right? And using the composition of function, we can define the inverse of any function. That inverse of a function is actually that function g for which g composite f is equals to x and f composite g is equals to x, right? So that function is known to be the inverse of function. Is that fine?
That one-to-one function are not always reversible on their range.
Right. One-to-one function need not always has inverse. For example, if you take only e to the power x, right? So e to the power x is an 1-1 function. Why it is an 1-1 function? Because via graph, you can observe that the graph of e to the power x is this. So you can take any horizontal line. That line will cut at most once, right? That's why we always use the phrase at most once. And not exactly once, at most once. Matlab zyada se zyada, it can cut the graph at most once, right? So via the horizontal line test, you can say that e to the power x is a 1-1 function. But what happens if you take any negative value, for example, -1, then we cannot find any x. Then we can't find any x in such a way that e to the power x is equals to -1. That means it's not an onto function. So that's why it's not a bijective function, and that's why it does not possess an inverse, right? So inverse, for having inverse, function should be 1-1 as well as onto. Both conditions are required. Because inverse is what? You have to, there's some processes given to you and you have to reverse that process, right? So if 1-1 is not there, that means for for two distinct output, if for two distinct input, if you are getting same output, then how can you reverse that process? Once you want to reverse that process, there will be some ambiguity in outputs, right? So inverse, you can assume that you want to go from this thing to this thing, and you want to reverse it back. So for that thing, you need 1 and undo both things, right? That's
Ma'am,
why-
I have some confusion in case of composition of functions. I have some confusion in determining the range and function, range and the domain of the outer function.
Okay, so let's fine. So let's go toward the domain of composite function. This inverse function is clear to everyone.
Yes.
Now I'll give you
Yes,
a
ma'am.
simple example. There you have to find out the inverse of that function, right? So if some expression is given to you in terms of x, and if you want to find out the inverse of that function, so what you will do, you'll try to express y in terms, x in terms of y. What do you mean by that? Suppose, yeah, I'll come back to domain and range of composite function after this topic. Okay. So suppose f of x is given to you in this form, that 5x minus 1 upon 8x plus 4. And they say that find f inverse of x, right? Then what you will do, you will try to reverse things in terms of y. That means this is your y is equals to f of x minus 1 upon 8x plus 4. Whenever we have to find out f inverse, what you will do, you will try to express x in terms of y. Here y is expressed as in terms of x, right? Some linear combination, some quotient type of x. Now, if you want to find out the f inverse, the first step will be express x in terms of y. Right. So if you do that, then what will then we have to do some calculation here, right? So that means y multiplied by 8x plus 4 is equals to 5x minus 1. This is same as 8xy plus 4y is equals to 5x minus 1. Now if we take 5x here, then it will be 8xy minus 5x is equals to minus 1 minus 4y. That means x bracket of 8y minus 5 is equals to minus 1 minus 4y. So that means x is equals to minus 1 minus 4y upon 8y minus 5. Right. So now what we did, we expressed x in terms of y. So whatever expression comes here, that is your f inverse of x. Right. So that means f inverse of x is actually equals to, just replace y in, as we know that expression of any function is given in terms of x only. That's why just take x in place of y. So that means minus 1 minus 4x upon 8x minus 1. This will be the expression for f inverse. Right.
Ma'am, this is the same method now where you can be used for finding the range of the above function. We just don't replace x and y.
For finding, right.
Range.
Correct. So what happened? What you want to say that if you want to find out the range of this function, this type of function, this quotient type of function, then what you will do? You will take make x is equals to y type of thing, and then observe what are the possible values of y could be. For example, here, if you take any x, this thing should be well defined. So whatever point this thing is well defined, then those points are actually range of that function. That means ultimately what you are doing, you are finding the domain of f inverse. Right. So whatever the domain of f inverse is, that will be the range of f. So this finding inverse is okay to everyone, right? If some expression is given to you, what you have to do, you have to first express y in terms of x, and whatever expression will be there, that expression will represent your f inverse. Is that clear?
Yes, ma'am. Ma'am, if a function fails the horizontal line test, then it is not reversible.
Obviously, because it fails the horizontal line test, then it can't be 1, right? So it can't be reversible. Okay. So now there is one written theorem way that suppose, not suppose anything, just a remark or a note you can take that that the domain of a function f is same as the range of its inverse f inverse, and the range of a function f is same as the domain of the function f. So sometimes you can use this fact to compute the range of any function, right? Because computing domain is quite an easy task as compared to finding out what is the range of codon, right? Okay.
Hello, ma'am. Hello.
Yes.
Ma'am, one function is reversible on the range.
If you restrict
Ma'am.
your domain to be range, then it will automatically onto. So that's why we can say one functions are reversible over that range. Yes.
Oh, okay. Thank you, ma'am.
So this is the remark. Now let's move toward the domain of composite function. So I already told you the method, how to find out the domain of composite function. So for finding domain of f composite G, what you have to do, first step, you have to find out domain of G, domain of the innermost function, right? And then second thing you have to do that remove all those x belongs to domain of G for which I think here you also have to find out domain of f also, because domain of f is also required. So find the domain of f, domain of G, and then remove all those x belongs to domain of G for which G of x is not a part of domain of f, right? So this is the simple two steps you have to do whenever you need to find out the domain of f composite G. And again, for range, there is no specific method. How could you find out the range? But again, you have to sort of do a couple of things, right? So for domain, there is one simple thing that find out the domain of G, find out the domain of f, and remove all those points from the domain of G for which G of x does not belongs to domain of f. Because what happened if this thing is happen, that means if G of x does not belongs to domain of f, then it's obvious that f of G of x is not defined, right? Not well defined. Right. So because of this thing, we have to remove all those x for which G of x is not a part of domain of f. Is that clear now?
Can
And
you give
same
an
thing,
example?
and you can reverse this process for G composite f, right? For G composite f, you again find the domain of G, domain of f, and remove all those x belongs to domain of f for which f of x is not a part of domain of G, right? Fine. Is there any doubt?
And please give an example.
Yeah, we already solved examples for this thing. The very basic example which sir also taken, that take f of x to be under the root of x and g of x is equals to 1 upon x minus 3. Right. If you do this, then first thing is, what about the domain of f? So domain of f is all negative values you have to exclude, right? Because under the root function is not defined over negative real numbers. So that means domain of f is simply 0 to infinity. And what is domain of G? So domain of G, since it's a rational function, and we know that the rational function has domains, we have to remove all those points where the denominator part becomes 0. That means the domain of G is nothing but all real number minus 3. Right. Now, if you want to find domain of f composite G, then what does it? So first thing, domain of G is real number minus 3. Now from this domain, you have to remove all those points for which G of x does not belongs to domain of f. So since domain of f is simply closed interval 0 to infinity, we have to remove all those points where G of x does not belongs to closed interval 0 to infinity, right? So for this, what we have to do, first we have to observe that where g of x is actually not belonging to this interval. So that means first observe for what values of x g of x belongs to, negative part, minus infinity to 0, right? So if we want g of x to be negative, that means if we want a g of x to be less than 0, then what does it imply? It implies that 1 upon x minus 3, this should be less than 0, right? So what does it imply? This is less than 0 whenever we take x to be less than 3, right? Because when x is less than 3, then this will imply x minus 3 is less than 0. And we'll get a negative term here, right? So that means whenever we take the value of x which is less than 3, I'll get gx belongs to the negative. So that means we have to remove because if we 3 is not a part of domain, so that means again 3 is not a part of discussion. So that means we have to remove minus infinity to 3 interval from r minus 3, right? Because this is the domain of g. So we are removing all those points where g of x is not a part of domain of f, right? So that means this will implies that the domain of f composite g is actually the whole real number minus 3, and we again have to remove minus infinity to 3. That means the domain of f composite g will become 3 to infinity, right? This is the domain of f composite g. Is that fine now? Yeah. So again, for find,
ma'am,
yes,
ma'am, इससे close bracket
9 को हमें remove
optimally
करना पड़ेगा ना?
just see, just tell one by one. Sorry, what?
Yeah, ma'am.
is it closed bracket or 3?
Open bracket, because since 3 is again not a part of domain of G. That's why.
Okay, thank you, ma'am.
Yeah.
Can
Yes,
you
Deepak.
explain it again? Can you explain this again? I can't understand.
Okay, so what we did, first we find the domain of f. Domain of f is simply 0 to infinity since it's a square root function. Then we find a domain of g, which is real number minus 3 since it's a rational function. And then we observe our 2 steps for a domain of f composite g. The domain of g, and we have to exclude all those points for which g of x is not a part of domain of f, right? So for that, what we observe, we find out all those values of x for which g of x is actually becoming negative, right? So we observe that if you take any x which is less than 3, then this x minus 3 will become negative. And when x minus 3 is negative, 1 upon x minus 3 is also become negative. So that's why we have to remove all those x which is less than 3. And again, 3 is not a part of a domain of G only. So that means the domain of f composite G will become real number minus 3 union with this interval, minus infinity to 3. So that's why the domain of f composite G become 3 to infinity. Is that fine now?
Yes, ma'am.
Fine. Okay. Now, that's all from week 5, I think. And now let's move toward week 6. I think there is one exponential function concept is there. So let's discuss that first. Okay. So a function f of x, if it is defined in this term, that a to the power x, where your a is not equals to 1 and a is strictly greater than 0, then this function is known to be the exponential function. Right. Now we have several properties of that function, exponential function. First thing is, let's look a graph of that function. So when we take a to be between 0 to 1, and when we take a is greater than 0, you guys know why we take these two restrictions, right? Because if we take a is equals to 1, then it will become a constant function. And if we take a to be negative thing, then obviously a to the power 1 by 2, such kind of thing is not well defined, right? That's why we impose two conditions when we define exponential function in general. Okay. So whenever a is between 0 to 1, the graph of exponential function look like this decreasing kind of behavior. And the y-intercept of this function is basically 0, 1. Because you observe when you put x is equals to 0, the value of a to the power 0 will become 1, right? And now let's look at the graph when A is greater than 0. Now here it actually works very nicely. It's an increasing kind of graph where the y-intercept is again 0, 1 because of the same case. Okay, these two graphs are important for you. That's a decreasing behavior, it's an increasing behavior, right? So using these two graphs, we can observe certain limits. That limit x going to infinity, limit x going to minus infinity of a to the power x, right? So in this condition, you observe that when x goes to infinity, this actually decreasing very rapidly, right? So that means as x approaches to infinity, this graph actually approaches to 0, right? And when x goes to infinity, it's some sort of, it taking much more higher values, much more greater values when we approach toward the minus infinity, right? So that means this limit is nothing but infinity. And in this case, if you observe, then limit x goes to infinity, a to the power x, and limit x goes to minus infinity, a to the power x. What will be this limit? Hello?
Infinity.
Infinity, right? And what about this?
0.
Right? Now here, some other properties are that what is the domain of exponential function. So you observe that we can define a to the power x for any real number. That's why the domain of this exponential function is actually the whole real line. And the range of exponential function is the positive y-axis, right? Because we cannot have any pre-image for negative real numbers, right? Because a to the power x can't be negative, can't be less than 0. That's why the range of exponential function is simply closed interval 0 to infinity. Open interval 0 to infinity, my bad, sorry. Because again, 0 can't be attained. It's a limit, that's why it's can't. Is that fine? Exponential function?
And can you explain how the limit x to minus infinity of a power x equal to 0?
Because it's actually approaching toward the x-axis, right? As we go over a minus infinity, then it's actually becoming very smaller, and smaller. And again, we know the thing that a to the power x can't be equals to 0. Right, a to the power x can't be equals to 0 at any point, at any real number. If you take, then a to the power x won't give us the output to be 0. So that means this x is equals to 0 is some kind of a barrier there. And since our graph is some sort of decreasing nature over this part, when if you approach over minus infinity, the graph is some sort of decreasing, right? Decreasing kind of behavior is there. So that's why we have a barrier there. And the graph is decreasing. So that means this limit will be equals to 0. Is that fine? Because we can't cross 0.
Got it.
Okay. So now these are the something about exponential functions. And one more thing, that exponential function is a 1-1 function because of horizontal line test, right? Okay. Is there any doubt on exponential function? Any fact which is not clear to you? Fine. Okay. Okay. Now let's move toward the logarithmic function. So what happened in the previous thing, we define our exponential function f of x is equals to a to the power x. So it's a function from domain to be the real number, and its range is actually 0 to infinity, right? And we get the thing, and this is the range, right? So if I restrict my exponential function with this domain and this range to be my codomain itself, then in this case, what happened when we restrict our range and when we take our codomain and range same, when we make our range to be the codomain, then that function will become onto automatic, right?
Yes, ma'am.
Okay. So when this thing happens, then exponential function will become 1-1 and onto, right? And whenever we have 1-1 and onto function, we can find its inverse. Right. inverse, right? So the logarithmic function is nothing but a way to express the inverse of exponential function. So that's why we define that y is equals to log base ax if and only if a to the power x is equals to 1. That means logarithmic function is actually the inverse of exponential function, right? So this is the basic definition of logarithmic function. As we have restrictions over a, so same restriction will follow here also. That means here a should not equals to 1. Here a should greater than 0, right? And since the domain of exponential function is real number and codomain is 0 to infinity, because of that case, we say that log base a of x is a function from 0 to infinity to the real number. So that means the domain of logarithmic function log base ax is actually equals to open interval 0 to infinity, and the range is real number, right? Okay. So these are two things. Now we'll see the graph of logarithmic function. So graph. So there's one remark I already told you that if simple thing that the graph of f inverse, is the reflection or reflection is fine. Is the reflection of the graph of f about y is equals to x. That means whenever you have a function f and you want to find out the graph of its inverse, what you will do, you will reflect its graph over y is equals to x. So we'll use this fact to find out what is the graph of logarithmic function, right? So I'll just show you by Desmos quickly. So suppose y is equals to, we divide our case into two parts when the value of a is between 0 to 1. So let's take 0.5. Then the graph of exponential function is this thing, right? This red line. And if you want to find out the graph of its inverse, what you will do, we have to take a reflection over y is equals to x. So that means the graph of y is equals to log base 0.5 of x is actually equals to this green line, right? Here you observe that this green line is actually a reflection of this red graph over the line y is equals to x, right? So this is the graph when this green is the graph when the value of a is between 0 to 1, the graph of log x, right? And again, in place of in place of the value between 0 to 1, if we just take the value greater than 1, then the graph of logarithmic function will become very easy to get. So this green one is again the graph of logarithmic function when your value of a is strictly greater than 1, right? So that means if 0 is less than a is less than 1, then the graph of logarithmic function look like this with the x-intercept 1, 0. And when a is strictly greater than 1, the graph of logarithmic function look like this, right? With the x-intercept to be 1, 0. These two things.
Can you show the Desmos graph once, please?
Yes. Is that fine?
Thank you, ma'am. Yeah.
Okay. So this is the thing. Now, using the graph, we can easily check the end behavior of a function. That means we can check the limits, n goes to infinity, n goes to minus infinity, and domain also. If you want to find out the domain of logarithm, you have to take care of this fact. The domain is 0 to infinity. That means at negative values, the logarithmic function is not well defined. Okay. Now let's look towards some limits. So limit x goes to infinity, log base ax. In this condition, what do you guys think? And limit x goes to minus infinity. Since minus infinity doesn't make sense here, as we are so far than minus infinity, because at negative value it's not well defined. So that's why in place of minus infinity, we'll look the limit x goes to 0, because the domain is 0 to infinity. right? So we look limit x goes to infinity and limit x goes to 0. Log base ax, what will be this limit? And limit x goes to infinity, log base ax. What about this limit? Limit x goes to minus infinity, log base ax. Again, here also we have to look at 0. So let's talk about first limit. What will be the value of this limit?
Negative infinity.
Minus infinity, right? What about this? This is plus infinity, right? Because as we are going closer and closer to 0,
Infinity, yeah.
Here also the limit is infinity, and here the
Yeah.
limit is minus infinity, right? So this is the end behavior of a logarithmic function. Right. Again, as the exponential function, logarithmic function is again a 1-1 function. As you can draw any horizontal line, it will intersect the graph exactly. So that's why it's a 1-1 function. And also onto function, because the range is my real number to real number. That's it. Okay. Now there are
there is a
simple.
odd sound.
You should mute your mic. Maybe your mic have some problem.
Like a cracking sound, yeah, ma'am.
Hello.
Ma'am, it is someone with a name
Yoha
Vadesh.
yes.
I'll mute all then. What's happening? I'm not understanding. Do you guys see?
Yeah, now it is okay, ma'am. There was some weird sound actually.
Okay. Fine. Okay. Now, properties of log, right? So there are very simple properties of log. So that log of mn is actually equals to log of m log base m plus log base a of n, right? These property actually helps you to find out some, do some algebraic multiplications and all those things. Right. You guys are already familiar with such properties, I hope so. And log base a of b to the power m is actually equals to, or n is here, then it's actually equals to m by n of log this thing. And the second is change of base, right? So that means log base a of x is actually equals to log base b of x upon log base b of n, right? Because of this property only, it is enough to talk about two logs. First thing is log base 10, because it's easier to handle. And the second thing is log base, which is more application based point of view, right? So these two are the commonly used logarithmic forms, which you can see in general. So this log is sometimes written as log only. So whenever this simple log is written, then you assume it to be the log base 10, right? And whenever this ln is written, then this ln is actually stands for log base e, which is known as to be the natural logarithmic function. Okay.
Ma'am, excuse me.
Yes.
If within the base, if it is written as n into a, then how are we supposed to simplify it? Instead of a to the power n, it is a into n. Yes.
This thing now. Yeah, there is no way to simplify that. First thing, what you can do, you can change your base over m, and then you can do. What do you mean by that? That this is, suppose there's some x here. Then this thing you can do as base m will be there, x will be there, and then log base m, mn. Right. Now you will apply formula here. Then it will become.
I think the m is a different base, right? Or does it mean that the same
you can
m?
take same only, because then m or m, this will become simplified. That's why I take it same. Then via the formula, now it's become right.
Okay.
Then this quantity will become 1. So in this way, you can simplify it via change of base using. Your voice is not clear, Aman. Hello?
Ma'am, explain the second last of the log.
Second last
Sorry,
what?
ma'am.
Here?
M by N log AB, I think. Yeah, second last.
This is M by N log base AB. This is a property of log, na? Like, your voice is not clear, so I'm just guessing what you are saying.
Send on the chat box now.
Just write down in chat box.
Ma'am, he's talking about that property only. Log A के power N and B के power M.
This property, you guys are familiar with this property, I think sir already told. Or this property you can, I mean, combining of this property and this power property is there, na? That N log base B, right? So combining with this property and change of this, you can obtain this property also. There's nothing new.
Yes, ma'am.
Okay. So that's all about the theory. Now let's solve some questions. So here I have some questions. So let's find out the first question. Explain this. Just give me 1 second. That's question number 1. Is find the range of x square plus 6 minus 56. We have to find the range of mod of x square plus x minus 56 plus x minus 56 plus 20. Plus 20 minus plus 20.
Ma'am, 20 to infinity.
Sorry, what? 20 to infinity?
Ma'am, 20 to infinity, I think so, maybe.
Okay, let's answer. I mean, let's give chance to everyone. So I'll give you 3 minutes to find out what's the range of that function. This mod of x square plus x minus 56 plus 20. It's kind of obvious also, but yeah.
Ma'am, range of mod will be always like 0 to infinity, right?
0 to infinity.
And there is 20.
Here
So
that mod is a polynomial
Yes,
function. So
ma'am, it's 20 to infinity.
here I think it's this polynomial is going downward toward, I mean, cutting the x-axis, right? There are 2 roots of this polynomial. 8,
it's
7,
quadratic
8.
now.
That's why you can easily say that the range is from 0 to pi. Fine. Yeah, 20 to infinity. So let me solve the answer of this question. Via this question, actually, I want to give you a little hint that whenever mod is there, how you can tackle the graph, right? For example, this is
if it is allowed, ma'am, then take another function in that mod like tan or something, ma'am. Then it will be a quite good question.
So for that, what I want, I don't want any zeros. So let's
first explain this.
Plus 1. This function. Now, what will be the range?
Nothing will change now.
Huh?
Ma'am, the range won't change.
Sorry, what?
Ma'am, range of quadratic is 0 to infinity.
Yes, ma'am. It's 20 to infinity. If you change the constant part of the quadratic equation, the range of the equation doesn't change.
Ma'am is asking
Yeah,
about a
actually,
specific
this
quadratic
also
function.
changes. If you take x square plus x plus 1, then range won't be from 20 to infinity, as I think. Because this function, this quadratic function, does not cut the x-axis, right? So if you find out the vertex of this quadratic function, what will be the vertex? Since you have to first observe that it's a parabola facing upward, right? First thing is this, that's a parabola facing upward. Second thing, what do we understand by vertex of that parabola? That where it located, right? So vertex of parabola is what? X is equals to minus b by 2, right?
Yes, ma'am.
So that will become minus b by 2. If we take, then it will become minus 1 by 2. So that means square plus x plus 6 plus 1.
And we forgot the shift.
Sorry. So yeah, so this is the vertex of this parabola, right? Minus 0.5 is the vertex. Now, if you add, if you take the modulus, then modulus won't change anything, is this function. But if you add 20, then your function will go up, right? So that means now the range of function is from this 20.75 to infinity. That means range is slightly changed. This is one thing I want to tell you, that whenever quadratic function is there in the modulus, you have to observe something. Otherwise, in many cases, if there are some zeros is present, and if it's cutting the x-axis and mod is there, then you can just reflect it and get your answer, right? Okay, so this is an easy function.
Got it, ma'am.
So another thing is little bit, I mean, if mod is there and some function is there, suppose f of x is there. Makes sense. One thing is this, suppose
Ma'am,
that
if mod is there and the quadratic function is in negative, minus x square,
if
then what
we
will be the
take
range?
that, then also modulus will become it positive then. Okay.
0 to infinity. Okay. 20 to infinity
That
will be
thing.
the range.
Okay, yeah, that also fine. But I just want to give you this fact only. That's the only reason I took that example. That suppose the graph of fx is already given to you. Suppose this is the graph of fx. Right? This is the graph of fx. Now, if you want to find the graph of modulus of fx, what you will do? You will reflect all those points, all those portion of graph which is below the x-axis. Reflect that
Negative
above
y-axis.
x-axis
Yes,
and make it to be positive. That means this portion will now get reflected over here. This is that. So that means if you take the mirror image of that portion, it will be like this. But again, the graph will follow here also. And then this portion also get reflected, again followed here, and then this portion also get reflected. So whatever this red one is, this red one actually denote the graph of modulus of x. So that's the usual way to find out the graph of modulus of x when fx is given. Is that fine?
ma'am. I have a question, ma'am, on this one. That ma'am, after we apply this modulus, it will be continuous, but I think at those critical points, it will not be differentiable anymore.
Right. Differentiability won't be there, but continuity obviously there. Yeah, right.
Okay, ma'am.
Because there are some corner.
Answer, ma'am.
Okay, so firstly we take, I mean, this answer is, its answer is 20.75 to infinity. The previous one, the answer is 20 to infinity, certainly. Because of the graph only you can say. I mean, first you will find the coordinate of vertex with respect to whatever value is taken there at that 20, right? I mean, if you want at 20, then the modulus of this thing is same because it's over the positive real axis only. And if you add 20 there, then it shifted 20 units upward. That's why the range is 20.7. Is that fine?
But we can't use this.
You won't use the Desmos, but you can find out the coordinate of vertex now. Coordinate of vertex is what? Minus 1.2. Corresponding this coordinate, the value of y is 0.75. Right? So that means your parabola is looking like this. And this is your vertex here somewhere.
Thank you, ma'am. Thank you.
Yeah. So via vertex you can see. Okay, so this one question is there. Now, second question I already solved that if fx is this type of linear function, then what about f inverse? They've already solved it. And we can easily find out the domain of f inverse also, right? This question is fine to everyone, right? Now, what about domain of x to the power 1/5? It's also an easy question. So, domain of x to the power 1/5. write down in chat box. Don't answer verbally. Okay. I'll give you 3 minutes to figure out or 2 minutes to figure out. Observe that it's an odd power of x to the power 1 by 5. 5 is odd. So, yeah, so many people got it right. So since it's an odd power of, the denominator is an odd number, that's why the domain of x to the power 1 by 5 is all real number. Right? Because whenever we have even power, so what happens? One thing you can guess here, that if you consider y is equals to x to the power 1 by 5, this will imply x is equals to y to the power 5. Right? And y to the power 5 is a function which is 1, 1 as well as on. That means if f of x is equals to x to the power 5, then f inverse of x is actually equals to x to the power 1 by 5. Right? This fact is clear. When we take f of x to be x to the power 5, then its inverse is x to the power x to the power 1 by 5. Right? And we know that the domain of x to the power 5 is actually the whole real number, and the range of x to the power 5 is again the real number. Right? So that means, which will implies that we know that the domain and range will get switched when we talk about inverse. So that means the domain of x to the power 1 by 5, which will be same as the range of x to the power 5, and which is nothing but the whole real number. So that's why the domain of x to the power 5 will become real number. Okay. So whoever said 0 to infinity, just keep in mind that whenever you have odd here, odd denominator, then that function will have a domain to be whole real number. The graph of that function is also, you can check easily, that suppose it's x to the power 1 by 5, right? Right. So this is the graph, this green one. So that means it is well defined over all real lines. Okay. Is that fine? Domain
Yes,
of
ma'am.
x to the power 1 by 5.
Yes, ma'am.
Now let's move toward the next question. So this one is done. Now, what about this question? That if f of x is equal to, actually, this is not a part of our discussion because it's based on differentiation. So you can take a screenshot of that question and try it out. It's actually based on week 8, right? Differentiability. Let's go toward the next question, question number 5. Again, it's a part of limit, but let's try to solve it. Because I thought you guys can solve question number 5, right? Try to solve it and answer in the chat box. Although these two are not a part of discussion of all. And again, sixth one is again not a part of discussion. So I think they're done with our question. So let's try to solve it, right? You guys are already know about differentiability and limit a little bit. So I think you guys can solve 4th, 5th, and 6th also. You want to
Ma'am,
discuss it?
share this PDF after the class.
Yeah, I'll share it. Last time I wouldn't share. Yeah, I'll share this PDF.
Ma'am, where you will share this?
In the chat
On
box.
the chat.
So just stay
Okay, ma'am.
at the end for a minute and remind me at the end.
Ma'am, in previous time I thought that in calendars you post these documents maybe in PDF format after the sessions.
After the session, what?
Ma'am, is there any option in that calendar that you can post there
No, you
after
can't
the
post
session?
documents on
No.
the calendar.
Yeah, that's the thing. We can't do that. So that's why I'll share in the chat box only. Chat box, we
Okay,
can
ma'am.
share PDF in chat.
Okay, ma'am.
This in Zoom chat. In Gmeet, we can't even do that. So I think that's all from my side. I just have these 2 or 3 questions which I have to discuss. Although you guys can try these 3 questions also, which actually based on limit and differentiability. Okay. So do you have any doubt from the
Ma'am, you solved these questions because I just now joined.
Actually, this is the limit and derivative. So I think in the next session, sir will solve this. That's why.
Okay.
Although I'll share the PDF, you'll try it out. These are not that difficult questions.
Ma'am, share the PDF now if you have already done it.
Okay, so now itself
Yeah,
I'll share the
please.
PDF. So that
Ma'am, I have a question. Can you answer that?
yeah, sure. Yes, what's your question?
I'll send it in the chat box.
Domain of f of x. Okay, yeah, just paste in chat box.
And the answer would be -3 to 1, na? Because the domain of fx does not depend on the domain of ln x. It will depend on the range of ln x. And range of ln x is R.
You're talking about which question?
The one Deepak has sent in the chat.
Okay, so we already sent in chat. Okay, so the domain of fx is -3, 1, then the domain of ff ln of x is. Okay, so here ln of x has a domain 0 to infinity, right? Now we have to remove all those points which does not, all those points of domain of x or domain of ln of x for which it's not a part of domain of f, right? So that means ln of x never take negative value, right? So okay, sorry. 0 to infinity is there.
No, ma'am. What do you say? Ma'am,
That
ln x range will
means
be
it will be
considered, na?
Share me. I think this question we already discussed in class. Okay, so what does it says that f of ln of x is there, and it's given that domain of f is -3 to 1, right? So you know that the domain of ln of x is actually 0 to infinity. So if you want to find out domain of f composite g, what we have to do first, this is the domain of g. Now we have to remove all those points for which ln of x does not belongs to -3 to 1, right? But is not a part of -3 to 1, right? But again, ln of x is not equals to -3 ever. Or we have to find out all those x ultimately for which ln of x is a part of -3. That means what I want all those x from 0 to infinity for which ln of x belongs to -3 to 1. Right. Those x I want that for which ln of x belongs to -3 to. That means -3 is less than ln of x is less than. But this inequality is always true since ln of x is ln of x is what? Log base ex. So that means the graph of that function will be this thing. Right. So if I want ln of x to be greater than -3, that means, okay, so this inequality need not to be always true because ln of x can be negative value. Domain is not negative, but the value of ln can be negative, right? So that means I have to find out what values of x will satisfy this thing, right? This inequality. So since here ln is the base e, so that means this increasing kind of behavior is there. So if we apply this e, that means e to the power -3 will be less than x is less than, right? So that means x should belongs to e to the power -3 comma e. This will be your domain, right? This is the thing you want to tell, right?
Yes,
Ma'am,
ma'am.
please repeat this.
Yeah, so actually what happens, domain of ln of x is actually 0 to infinity and domain of f is given that -3 to 1. So ultimately what we have to do, we have to take all those points for which ln of x belongs to -3 to 1. Then only f of ln of x is well defined, right? Composition function is well defined when this function belongs to domain of that function, right? So in place of removing, I am just trying to figure out which values of x will give us this property. Ln of x is an element of -3. Right. Just understand that whenever we want to find out a domain of function, what we need to find out those x for which that function is well defined. So here, if I want f to be well defined, f of ln of x to be well defined, this ln of x should be a part of -3 to 1. Right. So that's the thing we figure out here, that if ln of x belongs to -3 to 1, that means ln of x should be greater than -3 and less than 1, right? And since ln of x is an increasing function, we can apply e over this inequality and get that e to the power -3 is less than e to the power ln of x. But again, e to the power ln of x is same as x, same as x only, right? Because e and ln will get cancelled. You guys know that e to the power log base a of
Log
x
E.
same as x, right? Because of this property, we get it to be equals to x. And here e to the power 1, which is 1. So that's why x belongs to e to the power -3 comma 1. Is that fine now?
Yes, ma'am.
Now one question Sarah shared, so let's discuss that. The function f of
Yeah, ma'am. Can you please explain this option? I was little confused in this.
option. Yes, sure. So here the function f of x is given and it says that it is odd, right? So what is the odd function, right? So odd function means f of -x should be equals to minus of f of x. That function is known to be the odd function. And even functions are that f of -x is equals to f of x, right? So this is the basic definition of odd and even function. So here, if you take f of -x here, then it will become 1 plus 3 to the power -x to the power 2 upon 3 to the power -x, right? But here it seems that it's not equal to, quite in a form of f of x. So that's why what you will do, this is not an odd function, right? Because if you take common here, that means 1 plus 1 by 3 to the power x square and 1 by 3 to the power x, right? And if you take common there also, it will become e to the power 3 to the power 2x and 3 to the power 2x plus 1 the whole square, right? So not quite equal to f of x or minus f of x, right? That's why it's not an odd function. Is that fine?
Yeah, ma'am. Yeah, ma'am. Got that. Yeah. Thank you, ma'am.
Okay. So, any other doubt?
Ma'am, can you differentiate bijective and reversible function?
Any other question you want to ask from activity, practice, or anything else? Because that's all from my side. I just have these 3 to 4 questions and the theory.
Ma'am, am I audible?
Yes, Suresh.
Yeah, can you differentiate bijective and inverse function?
Can we, sorry, what? Differentiate inverse function?
Bijective function.
Huh? So the definition of bijective functions or something else?
No, I need to know what is the difference between inverse function and a bijective function.
No, both are same. There are just 2 names
Same.
given to them. Yeah.
Okay.
Huh. Both things are same.
One question I have sent it in chat box.
Sorry, what, Deepak?
One question I have sent it in the chat box.
Okay, yeah. Solve for x, e to the power 4x minus 2x minus 2. I think this, okay, e to the power 4x minus 2x minus 2. So let's solve it. So it's e to the power minus 2x. E to the power 4x minus 2x minus 12, or there is some power of x. Is this the correct form? I think you missed a power here.
Yes, ma'am. 4 power x and minus 2 power x.
Oh, it's 4 power x minus 2 power x.
Yes, ma'am.
4 to the power x minus 2 to the power x minus 12, right? So here, if
Yes,
you
ma'am.
apply ln both sides, that means ln of e is equals to e to the power this thing is equals to ln of. So because of the power property, this 4 to the power x minus 2 to the power x minus 12 will come here, and ln of 1 will become 0. Right. Now this thing can be written in form of 2 to the power. That means 2 to the power 2x minus 2 to the power x minus 12 is equals to 0. And we know whenever we have such kind of thing, what we will do, we will make some kind of substitution, because of which our expression will convert into polynomial, right? This is known as to be the converting polynomial method, right? So if you put t is equals to 2 to the power x, right? Then what will happen? Then we will get t square minus t minus 12 is equals to 0. Now it's a quadratic function, right? And we can easily find out the roots of quadratic function. So the roots will be t minus 4 and t plus 3, right? Is equals to 0. As the multiplication is minus 12 and the addition is minus. So that means t can have either value 4 or t can have either value minus 3. Now here we observe that which value of what value we can pick, right? So if t is equals to 4, then what does it imply? So it implies 2 to the power x is equals to 4. So we know that x can take such value. Simply x is equals to 2 will work, right? So this will implies x is equals to 2 will implies 2 to the power 2 is equals to. So one root we get here. But again, if we take t is equals to minus 3, then it will imply 2 to the power x is equals to minus 3. But again, we know that exponential function cannot produce a negative output, right? It's a negative thing. And the range of exponential function is from 0 to infinity. That's why we cannot find any x for which 2 to the power x is equals to minus 3. That's why this case will be discarded. So which will imply that x is equals to 2 is the answer. Is that fine? In so many cases, we use this substitution and converting to polynomial method. So just keep in mind, whenever you come across such kind of thing, just substitute it with some other variable and then observe the cases.
ln1 is always 0 and ln2, ln3. What were the value for that?
Sorry, what? ln1? Yeah, ln1 is 0. ln1 is also always 0 because we know the graph of ln x will have x-intercept 1, 0, right? That's why it's 0. But ln2 and ln3 have some different values, so it won't be equal to 0. Okay.
Ma'am, can you show an
Okay.
example to find the vertex using the formula x equal to minus b by 2?
Sorry, what? Can I show?
An example to find vertex using the formula.
Vertex is a vertex of parabola.
Yeah.
So if you have any parabola ax square plus bx plus c, then the vertex is actually equal to minus b by 2a and f of minus b by 2, right? This is the form, right? If you consider this to be a form, that's the formula, right?
Yeah.
In week 2, we find the limit of sequence 4a to the power n. So what is an first? Then we can find out 4a to the power n. Yeah, this question, Sangeeta, right? I already solved this question in video lectures, that when n is odd, n is even. So what you have to do, that let me explain it. So what happens when we have such kind of thing, then if they say that find the value of an, I mean, what you have to do, you have to find the limit of 4an, right? So if we find, then this is same as 4 times limit of an, right? So the single task is just to find out what is the limit of an, right? And whenever an is given in two partial forms, a odd and even, and since it's already given that the limit of an will exist, okay, so whenever an is given in these two forms, and since they say that limit of an is exist, what you can do, you can just go via the simplest form is given in the expression. Here it's given that if n is even, then an is actually equals to 5n square minus 4n plus 1 upon 6n plus 2n square, right? And this is same as if we take common n square and divide, I mean, cancel it, then it's equals to 5 minus 4 by n plus 1 by n square. And this is 6 plus 6 by n plus 2, right? And the limit of this thing, that limit n goes to infinity, when n is even, en is actually equals to 5 by 2, right? And it turns out that whenever the sequence has a limit, then its odd limit and even limit, both things are same. So this 5 by 2 is actually the limit of n. Limit of n is equals to 5 by 2. So that means the limit of 4an is equals to 4 times 5 by 2, which is equals to 10. Okay, so this is a one simpler way to solve it, that whenever sequence is given to you and it distributed over two parts, odd and even, so just pick and it's already given that you have to find some limit. I mean, here you get a sense that limit exists, right? So in such cases, what you will do, just pick a simpler one and try to evaluate it.
So, yes, even, ma'am.
Is that fine?
Oh, choose NS even. Why can't we choose NS hard? Is there any condition?
Over what?
I mean, A of n, that A of n value, when n is even, you have chosen, ma'am, 5n square minus 4n plus 1, like that something. But why we ignored odd?
Yeah, actually, in this question, actually, they say that you have to find the limit of 4an, right? So the limit of 4an exists only when the limit of an exists, right? Because limit of 4an is nothing but 4 times limit of an. And the limit of an exists if these two limits will approach toward the same point. That's the case happen, because these two will become a subsequences, and when a sequence has a limit, all its subsequence will approach the same limit. So that's why I only take even one, because even expression is a little bit easier as compared to odd. In odd also you can take, because here
Okay, we can choose also odd, but even is so easier, so it's just even. That's it, ma'am.
just take even. That's good. Again, odd you can take,
Okay,
but in odd also you have to substitute in place of n by 2. You can take n minus 1 by 2, right? Because whenever limiting criteria of there of this type of function, the what we can say floor function, right? So then you can take it to be n minus 1 by 2, replace it to be n minus 1 by 2, and then find the limit. So if we do so, then also we will come across the same limit. That means limit will be, this will be 6n minus n plus 1 by 2 and upon 7 plus n, right? So when you do this calculation, it will become a limit of 2 will be here, 7 plus n and 5n plus 1, right? So this is 5 plus 1 by n, and this will become 2, 7 by n plus 1. So this limit is again coming to be 5 by 2. That means whenever you have this floor function n by 2, you can replace this floor function with n minus 1 by 2 and find the limit. That will work, right? This is another thing.
Okay, ma'am. Thank you, ma'am.
Okay.
Ma'am, I have a doubt.
No, I have shared that question.
Yes, Deepak. This for 0 is less than a is less than 1 and m is strictly greater than 0, what we have to do? Log of base of am square. This is your question. I mean, there should be any other information. What we have to do? Deepak?
Yes, sir, this is the question only.
So what we have to do in this question? I mean, we have to find m, or
We have to find log base a m square.
so, but
value.
this thing is simply 2 of log base am. There should be some other information also, no? Because if there's no information about m or a or something, there should be something in the right hand side also. Then only we can find the value of a or m or something else. We can say that it's positive, but we can't say anything else. This is the correct question. Okay, so let's do other question which coefficients. This says that m to the power, I think, m to the power log of 32 plus 2 log of 3m is equals to m. I'm not getting where's the power and where's anything else. So can you share the screenshot? That will be fine. You can share the screenshot also. Or just verbally tell what is the question.
The question is m raised to the power log 32 base 32 plus 2 raised to the power log 3m is equals to 16.
Is equals to
16.
16 only. Okay.
Then what will be the value of m?
Then what is the value of m square or m?
It's
So
not,
this is the question.
It's not 32. It's log to the base 3 2.
Okay, 3 and then 2 is here.
Yes.
This
right.
thing. And then plus 2 to the power log base
Log
3m.
3m is equal to 16.
16. Right. So what you will do, we'll apply log base m both of the sides. Because we have to do that then only. Okay, so log base m of all this thing is equals to log base m of 16. Codomain is not given in the question, then yeah, we can assume it the whole real number by default. Let's solve this question first. So if we do that, then yes.
I think so. They have just exchanged 2 of m to the base 3. I mean, 2 to the power log m to the base 3.
I mean, this is here. This thing you want to say?
First term, I mean, m to the power log 2 to the base 3. We can replace it as
1 by.
Hello, ma'am. No, the question is correct, but I'm just saying, is it correct or wrong, my method? We can change this into 3 to the power log m to the base 2. Can I?
You can do that also. Yeah, I am getting what you are doing. So, but let's again we have to use log m also. Then we can change the base into 2 or either on 2 or 3 only. Yeah, but I think 16 is there, so it's okay to take this base to be 2 and replace this thing. So let's try. You can do that also. So if we do this, then it will become log base 2, 3 plus 2 to the power log base 3m is equals to log base m of 16. Right. So now there are so many.
The question was log to the base 3, then 2.
Okay, just confirm the question is. What's the question? Just tell me again. M to the power log
to the base 3.
Roshni, you will tell, your voice is clear.
Log to the base 3. Then 2. Plus
is over here or in the same thing?
I think down.
Down.
I don't know. He sent the question, so I'm just saying.
No, plus is between them.
Okay, plus is between them.
Okay. Then
2 to the power log base 3m.
And this is equals to 16, right? So what you guys did, that you changed the first this base and then you solve it, right? So you can do that also. Although there's some property of log where we can change that a to the power log base b of x. This is same as b to the power. Does someone remember this property? Base a of 1, something like this. But okay, fine. If we don't need it, we can.
Okay, ma'am.
So if we take just log base m, then it will become log base 3, 2 plus 2 to the power log base 3m is equals to log base m of 16. Right. Okay. So now, again, we have to change so many things here. So this is 2 to the power log base 3m is equals to log base m 16th minus of log base 3. Right. So this is 2 to the power log base 3m is equals to, this is 4 times log base m 2 minus log base 3 2. So now here also, if we do 4 of, we have to change this base into 3 now. Okay, so this is log base 3 2 upon log base 3m. So what's that? Minus of log base 3 2. So again we stuck at some point, although here we can make any simpler thing, that 2 to the power log base 3m. If I suppose this to be t, then it will imply that log base 3m is actually log base 2t. So that means that we have to use some substitution to find out what is actually happening here. Okay. So what I want to do, I want to change this term also in some way that it will become simpler to us. Because okay. So we can multiply all the 2 to the power log base 3m is equals to 4 times log base 3 2 minus log base 3 2 into log base 3. Okay. Okay. Although if I apply log base 2 here, then it will become 2 logs. So can we use some kind of substitution which will simplify our things?
The formula what I just said before.
You want to change this thing, or we can distribute it in this way also, no? M to the power. Yeah.
We can change m and 2. We can exchange them according to me.
So I try to say, ma'am.
Yeah.
M to
Your
the
voice.
power log. Yes, ma'am.
See.
M to the power log 2 to the base 3 is that what it has. We can exchange it by 2 log m to the base 3. I mean,
that's the property, no? That this property I want. There is some property that it will become x to the power log base ab. This is the property. This thing, I mean, this is same as what you are saying, 2 to the power log base m of 3. Is that you are saying?
No, ma'am, only a and x exchange, ma'am. B will be as base, ma'am.
B will be as only a and x will exchange.
Yes, ma'am.
Then 3 will be there. Yeah, this property we need. Otherwise, it will be much more. Okay. So if we do that, then I think it will be easy. Yeah, that's the deal of log, that you have to remember properties, then only. And then here we can multiply it, and m to the power 2 to the power log base 3 is there. No? So m to the power 2 to the power log base 3 is equals to 16. Now what we can do after this property, still we have this is 3 and this is m to the power 2. Okay, I'll try to solve it and then I'll post it in Discourse, or I'll let you know in the next session. I think I'm missing something, that's why. Or if we can use substitution here, that will also fine. What I think so, that this is same.
Ma'am, I found a similar question to this. Sir actually discussed this in one tutorial also, but it was a different question, but the same, like it was same. So sir used the same thing about this, but instead of 16 writing it as 16, I think we can write it as log to the base 2 raised to 4 and then we can just take it as 4. And then on the other side also we apply log to the base 2 rise to the whole thing.
Okay. So if we apply log base 2 to the power m, does that help?
I think so. It should solve the question.
Okay. So can you paste the description link here if possible? Although I'll solve it and paste it. It
is the 9th question of graded assignment 6.
Okay. And that's why I haven't solved it. But I think there is some property only we have to use in substitution. So if we apply this property where we can change the base and this thing, then it will be fine. So if I say this is equals to some, it's again 3/2 is there. Okay, just see in the tutorial lecture. Otherwise, I'll also solve it and paste it.
I have shared the pick of a question.
Yeah, if someone already solved it, just paste it. Yeah, Deepak, let's do this one. So we have to find out the value of this thing is m, then which of the following option is true for m. So we have to find out is this m is greater than, I mean, what's the range between m will lie. Okay, so since it is 1 upon log base 3 of pi plus log base 1 upon log base 4 of pi. So this is the value of m. So now here bases are all greater than 1, but although the value of pi is 2 point something something, right? So that means log base pi of pi, which is actually equals to 1. This is if we replace the base with the smaller thing, does that help? Or we can use the change of base. This question is, I think, solved in the video lecture. Is this the one? But so first I'll try to change the base of this log. I don't think that will work. So it's log base 3 of pi is actually equals to log base e of pi 1 log base e of 3. But that doesn't solve anything. Is greater than equal to 3.8. So if we change the base, that means we know that log base 3 of pi is equals to 1 upon log base pi of 3. Right? This thing we know via the fact of that log base a of b is actually equals to 1 by log base b of a. Right? So if we do that, then this 1 by 3 is actually become log base pi of 3 plus log base pi of 4. Right? And this is log m plus log n kind of thing. So we know that log mn is actually equals to log m plus log n. Right? So here we can use the reverse property, and this says to be this is log base pi of 1. So this is the value of m. Right? So now this value we have to find out what will be the range. Right? So first thing is this 1.78 something something is given. So if m is this, then what does it imply? If we convert it into the exponential form, then it implies that pi to the power m, because y is equals to log base a of x is there. So that means a to the power y is equals to x. Because pi to the power m is equals to 12. Right? So pi to the power something is equals to 12. So if we take m, if we take any value which is greater than 3.78, so pi is what? Pi is roughly 2.7 something something. So if I take its power to be 3.178 or greater than that, then that actually does not exclude this 12, right? Does it? So if we simply take in place of pi, we know that pi to the power m is actually less than 3 to the power, right? And 3 cube is actually, 27, so that won't help. So the value of m is greater than or equal to 3.78. This thing is true, because if you take any value of m which is greater than or equal to 3.178, then you can easily find out the thing. Although you can find the value of this log via calculator, but how we get
It's
to this?
2.17, ma'am. It's
This
2.17. Yes, ma'am.
2.
It's 2.17.
So that means the value of m is 2.17. So from that we can guess that this option is not true. This option is true, right? It's less than, it's also not true. In log base 2 is, this is 1, right? So again, this is not true. So the second option is true. Right?
Yes, ma'am.
Okay. Yeah, in this question, previous one, I think I have to see some of the properties, then only we can solve it. Okay. So is there any other doubt? If not, then we can wind up our session here. Okay. Thank you all for joining. I'll suggest you this, see that question over lectures. If not, then I'll also do in next session.
Thank you, ma'am.
Yeah, thank you for joining. Goodbye, good night.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Yeah, I'll share the PDF, updated one.